In this video, I want us to talk about the sigma notation, which is a shorthand representation of summing a series, right? And it is represented by the mathematical symbol sigma, which is a capital letter sigma, which is the capital letter S in the Greek alphabet, right? So in general, in a sigma notation, in front of the sum symbol here, we have tk, and at the bottom here, we have k is equal to 1, and at the top here, we have n, right? And when we expand this, we get t1 plus t2 plus t3 plus tn. And in this case, your tk is the general term, and this k is equal to 1 right here is your first value to be substituted. And your n here is the last value to be substituted. So this is how you read this. You say the sum of tk, which is the general term, from k is equal to 1 to k is equal to n. Let me write this down. So is sum of tk, which is your general term, right, from k is equal to 1 to k is equal to n, which is the last value to be substituted in the general term, right? So let's say in another case, let's generalize this one because this one can change at any time. Let's call it m. Let's say k from k is equal to m. Let's change here again from k is equal to m to k is equal to n. So why did I do this? I'll show you in a minute. So here you may need to find the number of terms in a sequence. That is why I generalized these. You understand? So since we have generalized that, let's find the number of terms. Number of terms in a sequence, right? So this is how you find the number of terms. The number of terms in a sequence is determined as the top minus, so the top number, I'm referring to this is the top number. This is the top number right there, and this right there is the bottom number, right? So to find the number of terms, you say the top number minus the bottom number. But it does not end there. You add a 1. That is your number of terms in a sequence. Let me denote it as NTS, number of terms in a sequence. So you say the number of terms in a sequence is equal to the top number minus the bottom number plus a 1. So in a more general way, we could say n minus m plus 1. I hope you now understand why I had to change that 1, k is equal to 1 to k is equal to m. This is why. So this is the general formula you can use to find the number of terms in a sequence. All right. Let's look at an example to get an in-depth understanding of the sigma notation and have some fun with it. So here's a beautiful example that we are given, which is, I think, if you could, I would suggest, if you could, please pause the video and see if you can work through it and then come back and check the solution and compare the solutions, right? This example would want you to understand the sum of the arithmetic sequence series that we have covered in our previous video, and I'll leave the link here. Here we are asked to calculate n if we are given that the sum of 3k plus 1 from k is equal to 1 to k is equal to n is equal to 650, right? So how would it go with this one? Right, so the first step is to identify what kind of a series or a sequence that you are dealing with. So here, since we have our general term here, this is the general term, remember? Since we have our general term here as 3k plus 1, and k is not an exponent, and k is also raised to the first degree, so this suggests that it's an arithmetic. So, right, so now we know it's an arithmetic. So what can we do now? So what I would suggest you to do is expand. This is the necessary step that you have to do. Expand your series, right? Let's do that now. So when we expand this, we get, this is going to be equal to 3 times, it starts from k is equal to 1. So we plug in the value of k is equal to 1 plus 1, right? Plus 3 times, what is that? That's 2 plus 1. And 3 times a 3 plus a 1 plus, right, plus a 3 times n plus 1. That is the last term. All right, so now what we need to do here is find our exact values. So that's 3 times 1, that's a 3 plus 1, that's a 4 plus 3 times 2, that's a 6 plus 1, that's a 7. And 3 times 3, that's a 9 plus 1, that's a 10 plus plus 3n plus 1. Right. Okay, great. So what we could do here is, now let's find the common difference as always. So our common difference d is equal to t2 minus t1, or whatever term, whatever consecutive term that you'd like to use, which is equal to 7 minus 4 is equal to 3. So our d is equal to 3. All right. So there's another equation that we can use here. Which equation is that? So the equation that we can use in this case is the sum of an arithmetic series, but there are two of them. Which one can we use now? Let's see. All right, so we have the sum of n terms is equal to n over 2 times 2a plus n minus 1 times d, or we could use this one which says Sn is equal to a plus l, right? So which one do you suggest we use? All right, in this case, I would suggest that we use the second one. And the reason being, we know the value of the last term. This is the value of the last term, right? And we know the value of the first term. So let's get rid of this and work with this one. Right, great. So working with this, let's plug in what we know. What do we know? We know Sn is equal to 650 and n over 2 times a plus l. But let's plug in these because we know the values of these. So the value of a is 4, the value of l is equal to 3n plus 1. Right, but we need to understand something here. What we need to understand is the n's in this case are not the same. Because the n here is the n for what? For the last term, for the last value that we substitute into this general term. It is not, and this n here is the number of terms in a sequence. So this n right here, what it is how do we find this n here? So this n here, this n here. So this n here is equal to, so I would like to change, please allow me to change this into m, right? And we are looking for this n, right? So the value of this m here is equal to, m is equal to n minus a1, which is the first value that we plugged in, right? Plus a1, right? So we get that m is equal to, because this 1 and that 1 cancel out, we get that m is equal to n. So because of that, now we can change this m and make it that n, right? Because we have seen that they are equal to each other, right? There may be cases where they are not equal to each other. Okay, all right, I hope you get that. Great. So let's change this m over there to our n, then we continue working. N, all right. So now this 650 is equal to n over 2 times 4 plus 3n plus 1, right? So let's solve the inside. 650 is equal to n over 2 times that's 4 plus 1, that's equal to 3n plus 5, right? So let's multiply out these 2 on the denominator, and then we multiply it out. We get this is 6.2 times 6.5 times 2, that's 1600. Yeah, so that's 1300 is equal to n times 3n plus 5. All right, great. So we distribute that n, and we get that 3n is equal, also we get that 1300 is equal to 3n squared plus 5n, right? We transpose that 1100 to the other side, and we get that 3n squared plus 5n minus 1300 is equal to 0, right? So now we can find the value of n using the quadratic formula, right? And we get that it is equal to minus 5 plus minus the root of, what is our b? Our b is 5 squared minus 4 times a. What is a? Is 3 times the value of c, which is minus 1300. Right, all over 2 times the value of a, which is 3. Right, so let's use a calculator to figure that out. What is that? So that is going to be 125, which is equal to minus 5. N is equal to minus 5 plus minus the root of that number, and which is equal to 125 over 2 times 3, which is a 6. Right. So now we know that n is equal to minus 5 plus 125 over 3 over 6, or n is equal to minus 5 plus, okay, I'm sorry, that's minus 125 over 6. So here you can automatically disqualify this. Why? Because this is a negative number, right? And we cannot have a 650 when we have a value of n equaling a negative position, Do you understand? I hope you do understand that. All right. And I could guess that this is going to give you a fraction. You can plug it in a calculator and see if it gives you a fraction. But I think it does give you a fraction. And we cannot have the value of n being a fraction, right? Because it's supposed to be a natural number. Right, it's supposed to be an element of a natural number because we count as in 1, 2, 3, 4 in that case. So this suggests that n is equal to, so 5 plus 125, that's equal to 120. So 120 divided by 6, that's equal to 20. So this suggests that our n is equal to 20. So this is not applicable, right? So we have our value of n. So this is the n that's on the top of the sigma sign over there, right? Of the summation sign over there, right? So once more, please, when you use this equation, please, this n may not be the same as the n. It's not always the same as this n over there. All right, when you use this equation, this n is not the same as this n over there. It's not always the case. We were just lucky that it was the same, right? Okay, so that's it for this video, and thank you so much for watching. And please do not forget to like, subscribe, share, and turn on the notification bell, because the best is yet to come. Bye bye.